This is what you would look like if you had $1 million. What would you do with $1 million? We all have some ideas about what we might do and what we might buy, but now ask yourself this: what would your kid do with $1 million? I bet you it's not the same thing you just thought of. With these new Trump accounts, this is actually a really good possibility. In this video, I want to walk you through what a Trump account is, where to go to set an account up, what to expect once you set that account up, and how that account can actually make your kid a millionaire. Let's get into it. Trump accounts allow parents or guardians to make contributions on behalf of their kid. And if your kid's birthday was between 2025 and 2028, the government will give your kid a free one-time gift of $1,000. The next thing we need to understand is retirement accounts. So a traditional retirement account is a special tax-advantaged account that allows investments to grow tax-free until the account owner takes money out. Trump accounts appear to be like retirement accounts that are managed for the children. The money is invested in a diversified fund of American companies, and when your kid turns 18, they will take control of the account. There are some examples given on the website, and in this video, we're going to look at the details together. We're going to look at contributing $1,000 per year, and we're not going to stop until age 59 and a half or 60. And we'll also be looking at the assumptions on historical market returns. The first question is, what kind of return can we expect? Well, JP Morgan says the average annual rate is 10%. Fidelity says it's about 11.5%. And Investopedia is at 10.56%. but drops to 6.7% after inflation. Alright, so inflation is the rate at which goods and services increase over time. For example, stuff 30 years ago had a cheaper price than they do now. The Federal Reserve keeps an eye on this and tries to keep it close to 2% annually. We'll assume 3% annually, as this is a bit closer to the historical average. Using the inflation-adjusted return means that whatever we can buy today for $1 million will be the same stuff that we can buy in the future. Great, so we can adjust our first two numbers based on the historical average inflation, and then average all three numbers to get the expected inflation adjusted market return, 7.4%. Okay, now that we have some data, we can actually see how compound growth works. Investor.gov has a nice compound interest calculator you can use to explore different scenarios, and I put the link in the comments. We'll use it to check out our scenario and understand what's going on. We'll start with that free $1,000 the government gave us. Then assume we have 59.5 years until our kid will pull any money out. We'll assume that we keep all the money invested in the market, earning our average value of 7.4%. And lastly, we'll assume growth is happening annually. Wow, with all our assumptions, we've turned a free $1,000 into about $70,000 by the time our kid retires. Now this is a science and math channel, so we're gonna do the math. For now, I'll just show you the formula, but in a minute I'll show you where the formula comes from. So if we plug in our values, we arrive at the exact same number as shown by the calculator. Great, but $70,000 isn't $1 million. So we need something else. Enter the annuity or future value calculations. Here, in addition to our initial investment of $1,000, we're also going to add $1,000 per year, or $83.33 per month, which is basically just a night out on the town. We use all the same market rate as before, and we'll assume the money stays invested for 60 years to make the calculations easy. And when we calculate, bam, over $1 million. What is startling is the amount of money added to the account in the last 20 years, which is around 75% of the value. This is the power of compound growth, and this is why these Trump accounts give your kids such a huge advantage in life. Getting that extra 18 years of growth gives an insane difference in the final value of the account. All right, let's actually do the math. The first thing we're going to start out with is our initial payment, which is $1,000. Next, we're going to add in our growth rate of 7.4%. And then we've got our monthly payment, which is $83.33. Starting value is equal to that P0 of $1,000. Okay, so the next thing we want to do is grow the previous balance at the rate of return and add in our full $1,000 for the entire year. So this is going to be 12 times our payment, which is 83.33, plus the previous value times 1 plus our rate. Next, we want to be able to drag this down for the full 60 years and see the effect. So we need to go in here and we need to make sure that these cells don't move. So we're going to preserve the row and the column of the payment, as well as the rate. And now let's go ahead and drag that down. Great, it's looking like it's pulling everything down correctly. So now we can go down to 60 years. And there it is, $1,038,481. So that is matching what we found on the investor.gov and this is the value that we were looking for. Here's the formula for annuity growth, where we pay in at each year a fixed amount. Again, putting in our assumed values of 7.4% and growth over 60 years, we arrive at a value of about $966,000. Okay, so now we want to use our formula and see if we can calculate the exact same thing. Since we just saw that formula, we've got the 12 times our monthly payment, 83.33, times, and this is a fraction, so I'll double parentheses it, 1 plus our rate, raised to the 60 for the 60 years, minus 1, and then divide again by the rate. Okay, we match the value that we found on the slide. That's good. So the question is, where did the rest of the money go, and how do we get to that $1,038,000? Well, you probably noticed there was no P0 or initial value on the annuity growth slide because it's starting with just those payments. So we need to add that back in because that was actually growing initially in time 0. So let's do that calculation. We've got our initial value times 1 plus our growth rate raised to the 60th. Okay, 72,000, that's a little bit greater than the 69,000 that we found, but that's because the 69,000 was based on 59 and a half years, not 60. And if we add these two together, we should see, there it is, the exact same value that we calculated to the left by growing year after year, and the exact same value that we see on investor.gov. The math is a mathin'. But what investments do we actually put into this account? What do we actually buy, and what actually gets a market growth rate? Well, for now, it looks like the accounts will be invested for you in some low-cost index funds with a focus on American companies. We can actually look at a stock screener and get an idea of what we're going to be able to invest in. We'll limit ourselves to U.S. equities and large blend. This is still a lot of funds, so we'll further down select to Schwab's Equity Select list, which is really like a lot of inexpensive funds. Now you can look at some of these funds, or you can just wait till the account comes out and then take a look and see what investments are available there. So if you've had a kid in the last year, this year, or you're going to have a kid in the next couple of years, definitely set up this account. You'll get a free $1,000 right away. And if you invest in those market accounts or those ETFs and you stay invested for a long period of time, say 60 years, there's a very good chance you'll get that market rate of return over time and the account will grow. And if you keep the account invested and you continue to invest dinner out per month, and your kid does the same thing when they turn 18, there's a very good chance that your kid will retire a millionaire. I hope you enjoyed the video, and if you did, give it a like and make sure to subscribe for more videos like this in STEM related areas. I'll see you on the next one.